Hello, everyone. Thank you for joining us today for a LinkedIn Live event. I'm Courtney Burt-Reed, Digital Marketing Manager at MIT Sloan Executive Education. Before I introduce our special guests today, I want to encourage you to leave a comment letting us know where on earth you're joining us from. You can also use the comment section to ask us questions. Hopefully, we can address most, if not all, of your questions during the hour. If you'd like to dive deeper into the topic, I suggest you check out Paul and Jim's upcoming course at MIT, Business Applications of Space Exploration, happening on campus this September 22nd to 26th. So mark your calendar for that. We're going to talk more about the course later on as well. Welcome on the LinkedIn Live event today. We have Dr. Jim Garvin. Dr. Jim Garvin is the Chief Scientist at the NASA Goddard Space Flight Center and Principal Investigator of the Da Vinci mission to Venus. He served NASA for, I think, over 40 years over his career, working to enable and deliver new science across the universe with attention to engagement and communication of amazing NASA results. And leading the conversation today is Paul McDonough-Smith. Paul is a visiting senior lecturer in information technology at the MIT Sloan School of Management. In his research and teaching, Paul creates key intersection points between technology and business. You've probably heard of one of the concepts, algorithmic business thinking, or ABT as we call it. And he also specializes in translating computer and data science into measurable business value that involves organizational capability, transformation, strategy, and more. So without further ado, I'm going to hand things over to Paul to kick things off for us today.
So welcome everybody, and of course, thank you, Courtney, and Jim, of course, thank you. I've got the unenviable task now of kind of living up to Courtney's introduction. One thing I should say from the get-go is, these bios can be quite long and what have you, and lots of information packed into them. To boil it all down to kind of a couple of simple points, I suppose I'm what I would call a digital presentist. I have lots of friends who are kind of technology futurists and kind of go to all of these conferences and, extol the virtues of what's coming next with technology. As a digital presentist, I'm very, very focused on what we have in front of us today, how we can best use that to create momentum and really shape the next potentialities and create the futures that we want and not only need for our organizations and for our society. It's interesting as well to hear kind of Courtney give this introduction to us both. What Jim and I thought we might do is just really, as a starting point, just recap on where our collaboration introduced you to our kind of work that we've been doing together over the last 5 or 6 years as really a starting point for today's exploration, okay? The exploration we're going to undertake. So in the dark, misty past, 5 or 6 years ago, I think it was now. Exactly. I'll do the words. You can do the. You can. I'll hum. You sing, Jim. Yeah. But 5 or 6 years ago, I had reached out to MIT and was connected, very fortunately, to Jim, and we began working on that concept that Courtney mentioned, algorithmic business thinking, which in essence is a toolkit. A digital language, a set of cultural kind of approaches that revolve or orbit around 4 key cornerstones. Firstly, kind of framing our problems in a way that kind of everybody who's working on them understands them and has a common definition, but then breaking them down, decomposing them into their constituent parts so that we can work on these kind of sub questions in parallel, drive efficiencies. The second cornerstone of algorithmic business thinking is pattern recognition. And I think within the world that all of our organizations and industries live within today, actually looking for patterns, not only within the problem set that we have in front of us or the data that we generate and collect, but also more broadly across our industry and, heaven forbid, even outside of our industry in adjacent kind of other areas as well. So ABT kind of tries to tell us that once we've decomposed our problems, leveraged kind of key patterns of success or failure, then we're in a good place really to be able to abstract, to kind of separate the signal from the noise, focus on the things that are important and leave those generalities to one side while we focus on the specific elements that are going to push us forward. And in this pushing forward, in this momentum, we arrive at the 4th cornerstone of ABT, which is algorithms. But in the case of ABT, these algorithms, everybody, are actually human and machine instructions. So they rely upon a recalibration of the jobs, the tasks, the activities that the humans will do individually and collectively, but then also the jobs, activities and roles that the machines will play. And it's meant to be a very complementary type of relationship. So whether that means the integration of AI, virtual realities, compute types of techniques as well, to allow us to go to places where humans might not easily be able to arrive, or actually to be able to create digital twins so that when we do arrive there, we know how to act and how to behave and how to actually achieve our kind of targets. So Jim and I kind of began using at NASA this process, this methodology, which was never meant to be a one-size-fits-all type of solution. And that led us into kind of building on some concepts that Jim had been working upon around the forever frontiers of technology and of space exploration itself. So in essence, what we were able to do was pull together the idea of digital exploration and combine it with the idea of forever frontiers. So to put it in a nutshell, I suppose, if we were to combine the billions of neurons in our kind of human brains with the billions of kind of galaxies, stars in the universe, if we were to multiply those together, we still wouldn't come up with the number of permutations that are possible for our organizations in the digital economy. So this forever frontier, this great expanse, we take one or two steps forward and the horizons shift as we kind of progress. And so really we used ABT and the principles of DEF-X and DEF-S to actually help us create our pathways and pathfinding types of activities. And in turn, this led us to BASE, the Business Applications of Space Exploration. And that's a new program that we're going to be running here at MIT starting next September, the 22nd, the week of the 22nd. But also really led us to a place where we could build connections between the key principles of space exploration and the key principles that will govern how our organizations move forward in this time of AI, of punctuated equilibria, and really try and make sense of the volatility all around us. So that was quite a long opening gambit, I suppose, kind of explaining how Jim and I have been working together. Jim, do you think I've done it justice? Is there anything you would add to this journey that we've been taking over the last 5 or 6 years?
No, Paul, I think the beauty of it is the intersections that it enables. We don't think of space exploration always about business frontiers that will have relevance to all of us people here on Earth. And yet they've always been there. And organically over the last 60 years of the government-driven space exploration programs at NASA and other countries, we've used the principles that you just described without realizing exactly how we were doing that. I describe myself as a digital explorationist because I can't go everywhere, and Lord knows they wouldn't want to send me everywhere. But the brave folks that fly should go wherever they want. But we can open the frontiers that are accessible as learning grounds and proving grounds for things that intersect with business. And by making exploration digital, we can extend ourselves in ways that adds value that folds right back into the terrestrial domain where we live. And it is part of our extensions as people. And you've heard a lot of talk about that. It's built into our DNA. And so I think, Paul, your description was extremely apt. It actually has historical precedence in the history of exploration as we look back across the centuries of phases of it. And I think they apply today as we look forward the 50 to 100 years that are on the business horizons of this class. So I'm a big advocate, and I thank you for having me.
Oh no, the pleasure, of course, is ours. And just for kind of everybody out there on the other side of kind of our screens, and for everybody who's joined us today, just to give you a sense of the flow of kind of the discussion that we're going to have today. We're going to start really by talking about why we consider space exploration to matter today. That will lead us into some opportunities to discuss the relevance to your industries, to each one of our industries. We'll then focus on perhaps, Jim, maybe one, or if we have time, kind of a couple of the experiments that we're kind of proposing to conduct next. And that will allow us then really to get to a point where we can open it up for questions from the audience. So just to kind of start off with regard to why does all of this matter? I kind of grew up, looking through kind of telescopes and in the back garden with my dad, kind of looking up at the sky, being taught kind of the names of the various stars. And I suppose in some ways, I began to kind of build an idea that space is out there. Of course, with you, I've kind of had the opportunity to learn that actually it's not out there at all. It's in here. We are part of space as well. And one of the intriguing things that I've picked up from our conversations over the years and our work together is kind of a series of really important dualities. Okay, so this idea that space exploration can be used for observation of our own planet to understand some of the challenges, some of the opportunities that we have, whether that be in terms of sustainability, whether it be knowledge then that can create new opportunities for industry, various types of spin-offs, etc., etc. And so I think, if you don't mind, perhaps if we could start at this point, if we agree that AI and the world that we're living in today, AI as a general purpose technology is actually in that Gouldian type of manner, punctuating the equilibrium, and we have a step change, hopefully kind of understanding some of the dualities we have in front of us will help us navigate or recalibrate some of our approaches. So I'll kind of pass it over to you, actually, Jim, to kind of share your sense of the ways in which space exploration and some of its dualities might be relevant to what you see in your industry and perhaps kind of spreading out to other industries as well today.
Well, thanks, Paul. So first, my industry is the curious universe that we live in, which, as Paul said really well, is not just out there. It's a nice term, perhaps coined in television, but we live there, so it's actually here. And that interaction with space is an opportunity. That opportunity can be realized sometimes more slowly than we want. And so taking that opportunity, using the tools Paul said, is a really big element of it. And in some sense, the AI dimension, to quote Paul, to punctuate the equilibrium of where we've been as we explore digitally and in person with brave crews that have gone into space. We're really at a big turning point in a transition. And we all know that. Investments being made to return women and men to the moon, augmented with AI as we open that very near and dear frontier to all of us, where we still have so much to learn. So for me, I think the intersection of this business problem space with the opportunity space that this forever frontier of space, and it is forever in the sense of how we might characterize it for us as people, that not in the sense of science necessarily, makes it very attractive because it's forever in all the dimensions of space-time that we think about ourselves. And those are those that also are relevant to real world problems back here on Earth. So let's just, take an example. I think the miracles that AI and the compute engines behind it are making possible now have been measurement limited as we look at space as a forever frontier. We haven't been everywhere. We haven't measured things enough to take advantage of what those tools in our toolkit today, in business, in life, can take advantage of, even in searching for, what entertainment we're going to use. But as we change the measurement capabilities in digital exploration, we open the doors to using the AI domain and toolkit better. And that will start close by, that as we look at our own planet and live better with the abundant and amazing resource space we have available to us, but also as we extend ourselves to the moon, to this lunar space. And all that is enabled by the engine of technology. Many of you work in your industries that opens up telecommunications, precision navigation, precision timing, IT solutions, not only here, but there as we go. And so the opportunity space is bringing those things together to solve problems in a more knowledge commodity space. And that's where ABT, this principle of def S being space, is so attractive. So today, we know a little about beyond the world we live on and its interactions in a very local neighborhood. It's the hood of our universe. But the bigger universe out there that we're seeing, we're starting to see better with amazing observatories like the James Webb, like Hubble, like the next one we're going to be launching called the Nancy Grace Roman. Those will start to entice us beyond to things that we haven't adapted to the business world that we live in. And that's where this intersection, this partnership Paul and I've had across many others as well, has, I think, been catalytic. So I like to be a catalyst. I'm not particularly good at much else. So I think that's where we are. And we'll talk about some examples, and there's an infinite space of them. So don't think this is complete, where we can apply these techniques to think about that opportunity space in digital economics that build on the digital exploration that's at hand. And really, the next decade is going to be an era of, I believe, paradigm shifting change as we become aware of new worlds, new places, new physics and chemistry, and maybe biology that we are just beginning to recognize the possibilities of. And that's in science, where everything is exploration driven. But in business driven, we have to translate that into the kind of things that Paul and I have been talking about for the last 5 years, about things that have benefit beyond just the obvious ones. So that would be one of the things I think so exciting. And it's ironic that the history of exploration of our world by great navigators, seafaring peoples, overland explorers has followed similar paths if you look at them through a lens of the 21st century. Now, they didn't have AI. It was an acronym that probably meant, something else, at least in English. So, we can take advantage of that. So, Paul, I'll stop there. And I hope that was a connection of utility.
Well, yeah, definitely a very important connection, a very kind of very important intersect point as well between your industry, your experience, and the broader kind of sea and mass of industries and organizations we, all of us here are part of. Based on my kind of research and teaching, I think it's reasonable to argue that exploration kind of driven approach, in fact, it leans on the scientific method, I would argue a little bit, in terms of exploring so that we can build an hypothesis or series of hypotheses that we then experiment with to collect insights, data or non-data driven, that will enable us then to kind of lean on your metaphor of the seas, to tack and to jibe our path forward and to evolve. So that 3E type of model of having permission in our organizations to explore, to actually turn up the gas on the creativity quotient in our organizations, such that we can experiment in disciplined, deliberate types of manners, okay, and collect the data, will enable us to evolve. And so previously, we might have kind of looked over the fence at NASA and thought, well, okay, that approach kind of works very well for them. But I would be inclined to suggest that for every one of us here, really, at this period of uncertainty or punctuated equilibrium, where there are so many opportunities, taking that type of exploration led approach is going to be very helpful. And I've got a specific question, or a couple of questions for you before we get into some of the experiments that we're conducting. So as we kind of sit here today in early 2025, we're talking, and kind of course, everybody, I imagine, kind of suspect everybody on this call is kind of inspired, has been inspired by the work of NASA. And when we look, for example, at something like perhaps the Apollo mission and the Apollo kind of period as well, it strikes me kind of sometimes that project had longevity or had a space in which to work that isn't always afforded within most industries. Yeah, we often have a 1 year, 2 year type, or even less kind of perspective on things. And so I'm cognizant or conscious of the fact that whilst it's true that you have longer term missions, I know for a fact that you have very short-term deliverables and all of the rest of it. So the way in which you actually operate, the way that you connect the technology to your operations, I think perhaps has some interesting lessons to be learned for all of us across our industries. And then these, of course, are the types of things that we'll explore in that base program. But would you mind perhaps giving us some insights around how, as an organization, or how you, with kind of your span of control and influence as well, how you actually connect these longer term projects into these shorter term deliverables and almost the urgency of activities and actions as well?
Sure, Paul. So one of the things that's a hallmark of the kind of programs you talked about, the Apollo program, for those of you, was the basically the masterpiece of engineering that sent human beings to both lunar flybys and to the lunar surface multiple times between the late 60s and the early 70s. And, you know, maybe it was an engineering feat ahead of its time, enabled by the wizardry of engineering at the edge and the deliverables that gave us the potential to do that, that we're now creating in the 21st century mindset with project called Artemis, that it will launch soon, return of a mission with crews around the moon and back home, and then ultimately commercial access to the moon and also people back in just a very few years. That masterpiece of engineering was set up with a set of milestones, and milestones to give a rapid return on investment, and also to advance engineering against the challenges of inventing the future we need to enable to do what we said we would do. We didn't start with digital exploration. We started with an early intersection of it with human-based exploration, which we're very familiar with. And yet we ended up with an era, a profound era of enhanced digital exploration for the last, you know, several decades, as we've prepared for the return of people to deep space. So the beauty of it, Paul, is that the training we've gotten, it's kind of like an AI on people, was to advance engineering in bite-sized steps that have spin-off return on investment that allow us to do many great things. And I think that's the message. The example I like to give that is, I think, very reasonable is, as we've invented new measurement techniques that really were resisted in the community, measurement techniques that allowed us to see things that were previously unmeasurable, there have been a lot of naysayers that have said, you know, these approaches will not work. And so we've been able to demonstrate them by virtue of, if you will, robotic techniques. We can fly, you know, unpiloted airborne vehicles carrying these techniques to new places on Earth. We can go into the sea. We can do those things. And anyway, that's, to me, one of the things we've done. And one example I like to give is, you know, most people probably know this, but we mapped the surface of Mars to enable the future of robotics and human access to Mars with a technique called laser altimetry. And when we first proposed that to the community of experts, people said, well, you know, that's a very high risk. It's not going to work. And so we had to head off the fears of advancing technology, which included IT and other measurement techniques with active optical systems, lasers, you know, scary things. This now 30 years ago, we had to advance those things so we could open the frontier. And so now we live and bask in the glow of having mapped Mars with millions of laser altimeter measurements, good to, you know, scales of tens of centimeters, that would have never been possible without the open-mindedness that we were able to use. People said it would never work. Well, it's the basis on which we land large payloads on Mars now and plan those for returning samples of Mars. I just brought with me a little friend, piece of Mars, just to remind you, you know, this is good. And these samples also are little, you know, they're artifacts of where we're going. So, Paul, I think the message in a nutshell is we advance with purpose, with milestones that enable return on investment quick in the case of trying to reach a great goal. We'll be sending missions to fly around in the atmosphere of Saturn's moon Titan. That didn't happen overnight. And it's a long trip, 1 billion kilometers to Saturn, worthy, by the way. And so we don't instantly build for 10 years and fly. We design in steps that allow us to make progress toward these things. And that's the beauty of what we've been able to do, starting with Apollo. Project Viking is coming up on its 50th anniversary, the first robotic landings on Mars in the mid-70s. Projects like Voyager and Galileo have opened the outer planets, where we're going back with the Europa Clipper mission to the great Jovian system. So these are things where we've learned in steps. We've punctuated the equilibrium with new capabilities that now become de rigueur. They become the way we measure things. And sometimes we forget when we started that these things were resistant. So to your point, Project Apollo broke the ice for us to get some of these ideas going. And we've been able to sustain that in the modern digital exploration world. We now compete missions in science and engineering to explore places, like the mission we call Da Vinci going to Venus is a mission competitively selected on the basis of the kinds of competitive selection that happens in the business community all the time. You select for that which can be afforded to return investment as fast as possible to make the biggest difference and to produce knowledge commodity. And that's, I think, one of the hallmarks of how NASA today is evolving toward the NASA of the future. I hope that was at least a little sampler.
No, very, very, very interesting, in fact, in terms of, and somewhat reassuring that kind of you face the same kind of business-related challenges that we all do. This idea of kind of envisioning and building your kind of missions out and competition to actually have selection and funding and kind of support for these, and then having a series, almost reverse engineering this to have a series of milestones that you kind of that you hit, you learn from, and kind of move forward in that way, I think is something that we would all recognize. I'd like to kind of explore or kind of dig a bit deeper though into one of the points that you made. When kind of from the outside looking in at NASA, it's very clear the courage of a number of individuals. Yeah, I suspect, or kind of it's obvious, isn't it, that at various times in the history of kind of space exploration, it was an incredibly, and still is, incredibly dangerous undertaking. But can we just explore for a moment the courage of the actual business and organization? Yeah, because when you talk about kind of naysayers and kind of having to prove the validity of new approaches, of breaking through into new frontiers, etc., proposing new metrics of value, new units of measurements, so sometimes it can be quite, from a personal experience, quite deflating when you kind of have faced those challenges. How does NASA, or how have you seen your teams actually convince and move the business and the organization forward in terms of convincing people and moving them into a place where you can actually then get on with the catalytic business that you're interested in?
So, Paul, that's a highly relevant question. I think, the courage to pursue requires some key elements. One is being convinced ourselves that we have the people, the tools, if you will, the infrastructure to do the job. And that's a real key element. To digitally explore still requires the infrastructure of telecommunications, IT on site versus IT here, if you will, and translating what we learn and what we're able to return into the commodities that allow us to ultimately characterize, to understand, to predict, to use, and to apply. And so in many cases, that's required many steps. When we compete our programs at different levels, the price of entry sometimes is 1,500 page technical proposals of, that's the unit of entry. That's a lot of work for a lot of women and men. And it seems like maybe, that's not the most efficient business model for getting in the game. But at the sub level, those competitions are how we put together our teams. And so I see digital exploration as a team-based activity, like a team-based sport. And it's not always about winning. It's, we're reminded that in the season of Super Bowls and other great sporting events. But it's about playing the game to advance the ball and to advance the situation. And that's, I think, the beauty of how we work. The courage to dare to explore people on the moon, returning to the atmosphere of Venus to study a place that, is a maelstrom of dynamics and chemistry that's largely uncharacterized. These are, not for the faint of heart, but in doing so, what we learn from the application of technology and teaming with different subsystem engineering solutions allows us to solve other problems. And that building that toolkit, like you said with ABT, is really key. And that includes the algorithms. We're in going to these new worlds, we invent algorithms to solve problems, to return samples from the asteroid Bennu, recently returned to Earth in the Utah desert in 2023. Priceless samples of stuff we just don't have here that tells us about there to relate to here. That is an indication of we had to invent tools to allow robots to sample another world where the physics and chemistry weren't well known. And we experienced a very dynamic effect when we did a touch and go, assuming we would vacuum up the materials, and literally the asteroid unburdened itself upon us as we made the sampling. And the engineering tools we had developed had the capacity to solve those problems. And that's one of the beauties of the NASA system, is engineering a solution that can handle the exigencies that we have to make it valuable, so that eventually it can be commoditized to not have to be able to handle every single, contingency. And I think that is, it's not really a spin-off. It's a feed forward to what we've done. And NASA is just one example of that. Of course, we have this in many other domains. So in the digital exploration of space domain, those are the hallmarks of the success that we've seen. And those are just a couple examples. I mean, many of the things from Apollo in the late 60s and early 70s are fed forward to allow us to do missions and have capabilities here on Earth that we didn't have. And they didn't always work. We didn't get fault-tolerant computing right on the Apollo terminal entry, descent, and touchdown. But we pushed it to a point where we can now do those things more autonomously. And that will enable things in the business domain on Earth, as we digitally explore in a digital economy, to do new things and to find new opportunities. To me, that's the excitement of this time. We're ready to take on those challenges. We have robotic missions that are commercially enabled, going to the moon as we speak. That's the future, and that's taken a while to get there, but I think we're ready to explode in this punctuated equilibrium.
So I love that kind of phrase, the courage to dare to explore. And I don't think there's a single person kind of on today's, or here with us in today's session, that doesn't feel that kind of draw towards courage and exploring and creating those new futures, whilst appreciating that, you're going to have to run through a few kind of walls, or you're going to have to go under them or over them or around them, or what have you. As we define the new metrics of value, the new units of measurement, the new ways of working. And you mentioned the point around kind of teamwork and digital. And I think it's as true for AI as it is for other areas of digital work as well, that it's a multidisciplinary, interdisciplinary kind of set of activities. So that ability to not only to be curious and to be creative, but to be collaborative, to actually be conciliant, that idea of unity and unification. So to be drawing kind of positive things together, looking at our problem sets, not just for the patterns of success, but exploring those of failure as well, okay, to be guiding us forward. So as I've listened to kind of your insights over the last kind of 10 or 15 minutes or so, I think some of the key dualities or some of the paradoxes and kind of ways that we might look at this include actually recognizing, to borrow from Danny Kahneman's kind of work, the idea of thinking fast and slow, okay? Almost having a duality, a two-tier kind of speed. So we have the longer term mission, but then we have the individual launches and the activities and the milestones that we kind of track to, and that we use as our kind of staging posts and signposts to kind of future progress. I also very, very much think it's relevant the way in which you've been speaking about, remember the optical measurement type of thing around using space exploration to help us unearth kind of realities on our own planet. Kind of reminded of the T.S. Eliot kind of lines around we shan't cease from exploration, and at the end of all our exploring will be to arrive back at the place where we started and understand it for the first time. Okay, so there's a kind of an interesting duality there as well. This visioning and envisioning and kind of the reverse engineering, it kind of hints to me at almost a kind of Darwinian type of evolutionary type of natural selection, if you will, where fundamentally quite simple, whether it's algorithms or kind of strategic approaches, when they're repeated and replayed, actually create some interesting complexity in the system and the opportunity for development. I mean, within the AI and machine learning, deep learning world, we've seen this happen with neural nets, and the way that they kind of the repeat and the replay kind of has allowed us most recently to kind of power LLMs and generative AI and what have you. But also in our organizations, kind of, I suppose, a question that I pose to everybody here is what are the 4, 5, 6 kind of simple rules or simple algorithms that you can repeat and replay to create the culture of exploration, of that creativity, of that forward motion, of that resilience, really, that commitment, the courage to actually invent your futures, not kind of wait for others' futures to be kind of thrust upon you. Okay, so I think there's a lot of linkages or intersect points between space exploration, organizational exploration, and developments that, of course, we will explore further in the program that we're launching in September. What I might ask us, if it's okay, Jim, we might do now, is actually kind of talk with the team here about one of the key kind of experiments that we're proposing around with ABT type of thinking, those 4 cornerstones, to actually explore the opportunity for universal quantum compute farms on the lunar surface. You know, the idea of taking advantage of those permanent shadowed regions, the PSRs, kind of clearly kind of at a lower temperature than we would experience here on Earth. But yeah, if you wouldn't mind kind of just walking or talking us through kind of one of the ways in which you think this ABT kind of DEFS type of approach might be practical with this type of experiment.
Well, thanks, Paul. So let's follow the paradigm that Paul talked about for a minute. So we will have an opportunity as we return to the moon with systems and infrastructure to support activities that go beyond just existence, you know, surviving to return. That is a great thing to do, and we extend ourselves in going, and that, you know, is part of our culture, our DNA. But in a business sense, what opportunities are there other than the obvious resources that the moon presents, some of which are actually scientific resources, histories of systems that we can see on the moon that we don't have here on Earth or are not preserved here on Earth? That is the science stuff, and we know how to do that. But what other dimensions of opportunity are there? Well, one of them is, as we go back to the moon with women and men and AI and robotics and all the systems, the utilization of what the moon presents becomes an opportunity. And the moon is not Earth. It hasn't been, and maybe that's a good thing. We can learn from our beautiful moon. And so one of the opportunities is environments on the moon that are very unique. And on the moon, portions of the moon are in permanent shadow. They have not seen the sun in 3 billion years, plus or minus a few hundred million. Forgive me, Paul, for being inexact. And so those places are amongst the coldest in our accessible solar system. Yes, we can go to Pluto, you know, 39.5 times farther from the sun than Earth. Pretty cold, pretty cool. We've flown by with our New Horizons mission. But right here in our neighborhood, at the moon, we have these cold traps where the temperature is in the 20 to 25 Kelvin domain. These are virtual dilution chambers at hand, near to where current planning has us establishing places of landing for humans as part of the Artemis program in the very near term. There's a near-term system happening. We will go to the edge of these places as we return humanity to the moon. And that offers the opportunity to extend through the lens of business. What can we do there? And as part of going, we need infrastructure to be situationally aware with telecommunications, precision navigation, timing, imaging, so we can track what we're doing and don't jump into a permanent cold trap, since, you know, it looks good in the TV shows. Not the easiest environment for we to adapt to, just as is not 7 kilometers deep in the ocean. So the idea is, as a stretch idea, not engineered completely, is to say, so what do we need to advance the kind of universal quantum computing we would all love to see as a game changer in the compute environment for Earth that would take advantage of the moon? Well, what if instead of building dilution chambers underground in great facilities in our businesses now, we use the moon as a place to establish such capabilities, or nearly those capabilities, right next to where we're living and working in base camps established by people and robotic tools on the moon. And so if we imagine the moon becoming sort of a cloud quantum computing frontier for business, so that we, through the systems that we now use in the cloud on Earth, are extended to the moon as part of using the moon as a resource for us to expand ourselves in a digital economy. Imagine that being one opportunity. Of course, it needs to be tested. There need to be milestones. We need to decompose it and use techniques to understand how that would happen, because this is a new technology, not, you know, like the classic silicon-based computing that we use now, and the, you know, the von Neumann architecture we're also used to, the Turing basis, but moving into a new one. So the opportunity is to use the moon to enhance the opportunity for computing that will be of benefit to humankind as a business proposition. And so how do we do that? Is this crazy? Is this a logical experiment base to try? And we're doing new things on the moon with robotics and with the humans returning that are experiment based. Will this be good enough to advance the ball? Can we extract enough water? Can we use helium on the moon embedded by the solar wind as an energy source for the future? All these kind of great ideas that have real, you know, business model relevance. But this is one that uses the moon's environments. And we have other environments in deep space, including in other worlds, including Mars, asteroids, metal asteroids. We're on outbound to one now with the Psyche mission that would also involve this. So the question is, as an exemplar, is there any reality in this idea space going forward, perhaps with initial steps that are experiment based, and others that become, you know, part of the business culture of using the moon as we go back to sustain a presence there, to be able to go to even more interesting places for all of us, you know, such as Mars just being one of many. So that's the question, Paul. The engineering details are, you know, they're the homework assignment, but the engineering of this from a business model sense as an opportunity space is what excites me. I think UQC, the University of Quantum Computing, is intrinsic to our future, not only digital exploration, but digital economics. And so how do we advance it? This is an idea. Forgive the little sketch here. It's you know, there aren't floating dilution chambers hanging in permanent cold traps exposed to space radiation, a lot of other details that obviously are not shown in this graphic. But just imagine that as one of the many ideas we can all come up with. So Paul, I hope that whetted the appetite.
I think it's fantastic, and kind of if we take a couple of steps back, you know, almost like those pointillist artists, you know, when you're in kind of a cathedral as a school kid looking at kind of some mosaic. When you're very close to it, it's hard to make out the picture, isn't it? You can see the colors, but it's only when you take a few steps back that the actual picture and the contours come into shape. What I got to take from what you've just said there is that it's so important to actually frame the question, the problem statement. So here, the problem statement being, can permanently shadowed regions accelerate the development and support of quantum computing systems to meet the demand on planet Earth right now? Okay, and from there, I'm moving forward. And so from there, you have the opportunity to decompose, to look for the patterns, do all of those kind of abstraction kind of levels to create kind of the solutions, the humans and machines working together algorithmically, so to speak, or taking advantage of each other's strengths, complementing each other, et cetera, et cetera. And I think that's a really important lesson for each one of our organizations and teams today, because if we accept, if we reasonably accept that kind of AI is kind of providing us with some new squares to move to on the chessboard, it's not simply kind of the linear extensions of our strategy that we need to be looking at, but also kind of completely thinking outside of the box, exploring, experimenting to evolve our organizations. That requires us to think and act in different ways so that we can create and satisfy and excite our kind of existing and emerging clients in kind of new and exciting ways as well. And let's not forget, also as well, inspire our workforce, okay? Inspire our workforce to actually apply that discretionary efforts to increase their kind of inputs so that we can create better outputs as well. So I'm just conscious of time. We want to get to, we want to give some opportunity for kind of questions from the group. Can I just make a couple of closing comments and then pass over to you, Jim, as well for some closing kind of comments. So what I'd like to kind of share with everybody, or kind of pull together from today's discussion with Jim, is that I think we're at a really interesting space where the, no pun intended, where the digital exploration of forever frontiers isn't limited to space in terms of the physical kind of physical frontier, forever frontier of space, but also within our organizations. We have so many potentialities and opportunities, but which ones are we going to solve for? What are we actually going to go after? And in the base program that we're kind of putting together and building, it's with cross-disciplinary, interdisciplinary kind of representation across MIT and with Jim, of course, from NASA. It's almost a dimensional analysis that we're looking at. We're pulling together the economic, the societal, the sustainable kind of prosperity-related kind of concepts that allow us to take advantage of lessons learned from space exploration and actually create prosperity, create new jobs, create better jobs, create other potentialities. And that's going to require us to think outside of the box, to actually define new metrics of value, to get up and close, to explore, to touch the technologies, AI and other technologies as well, so that we can build those hypotheses that we can explore and actually give ourselves the permission to create, and those in our organizations to create in new and exciting ways. So I think that the kind of closing comment I would make is that we have an opportunity to leverage the dualities that we've spoken about, to explore the what ifs, to have envisioning, but also reverse engineering, and to really give it all that we possibly can on a daily digital presentist type of way to create the opportunities that we want for our organizations and societies as well. So Jim, kind of pass it over to you for some closing comments, and then we'll open it up for some questions.
Well, thanks, Paul. And really, I just have a couple simple ones. And one is the observation that this digital exploration of a forever frontier that is space is also an intersection with this, truly paradigm shifting computing as an exploration tool, which is enabled by what some of you do, and by the ability to transfer that into the space domain as, a proving ground, in some sense, as a test particle for how we move. Today, quite frankly, we are limited by computing and telecommunications as we explore. And that limits how we can apply AI techniques, as Paul said. We can't machine learn if we don't have anything to learn from.
Yeah.
Because, it would be interesting. It would be a kind of a recursive problem to learn from nothing, kind of. And so, but we're in an era where we are explosively learning and measuring. And so as we measure to the idea of dimensional analysis, but not applied to physics and chemistry, which we all love, trust me, wonderful, but applying it to sort of the business domain, what dimensional analysis will enable the benefits that you seek in your organizations as we continue to explore across these new domains, not just space. I mean, deep ocean, nanoscale or picoscale, all those are relevant. So I see this opportunity, being, we're at the cusp in the Stephen Jay Gouldian world, the viewpoint, that we will be puncturing the equilibrium so that how we explore will determine how we make business possible in new domains here on Earth, in this sort of knowledge commodity marketplace that is how we all are turning out how to live. And exploration is part of that, because we can stretch and catalyze and have the courage to do the things that Paul said as we explore places to bring it home, to better understand our position here on our home planet, where we live and work and play and, and sustain ourselves. So this opportunity space is enormous. I'm excited to be working with Paul and you to try to at least ask some questions, provide some perspectives. That's all we can do. We're sort of like poor people's machine learning, people learning here, and to open those frontiers. And I think they're boundless, and how we play in this domain in the next 5 to 10 years, I think will be, a lever arm into the future, so that, space will become part of us much more so than it is today. So I'm excited. I like to say never wait to wonder. I think that's the state we're in now. Wonder is everywhere. So let's dare to wonder and go for it. So Paul, back to you.
Thank you. And I'm going to pass the baton a little bit to Courtney as well in terms of questions. Courtney, I saw in the comments or kind of the private chat that you shared one from Susan. Let me know if you'd kind of like me to make a stab at answering that, or kind of if you've got other questions that you'd like me to, or like us to go after.
Yeah, we've got a couple of questions rolling in. So folks, please don't be shy in the comments. And yeah, the one from Susan asks, what do you think about the comparison between DeepSeek and Sputnik? And what are the implications for both AI and space? And I think that question, it's a wonderful intersection. Paul, if you'd like to take a stab at that question.
Yeah, I think I can take a stab at half of it. I can talk about, in a very brief manner around the AI side of it. Oh, that's clear. Susan. And this is kind of, I actually know Susan. Yeah. And honestly, everybody, this is not a planted question. Yeah. But how kind of coincidental that actually knows it. So Susan, I hope you're well and Happy New Year, et cetera, et cetera. So the question, what do you think about the comparison between DeepSeek and Sputnik, and what are the implications for both AI and space? Jim, are you okay if I take the AI bit and you kind of hit the space bit? So, okay, I have, of course, kind of aware of kind of what's going on with DeepSeek. I have to admit, I haven't played around with it an awful lot, but I've read a lot of the literature, etc. What I would say is it's super useful, again, like those pointillist artists, take a few steps back and have a look at kind of what's going on in the AI space here. If we were to roll back 50, 60, 70 years, what we've seen is kind of that there have been major breakthroughs, haven't there? We went from AI into machine learning, into deep learning, to generative AI on a pathway to artificial general intelligence. And fundamentally, and I know, please, I apologize that I'm oversimplifying all of this, but fundamentally, each breakthrough was designed or created or inspired to fix a fundamental flaw or a problem with the previous generation of kind of the technologies or techniques. So AI kind of into machine learning, the if-then types of rules, the idea of Polanyi's paradox, that as humans, we know more than we can tell. It's not always easy to explicit and tacit knowledge. It's not always easy to codify certain kind of activities. And if you can't codify it, it makes it very difficult to kind of automate it, et cetera, et cetera. So what we saw then was the transition to machine learning, whose problem kind of, again, I apologize to kind of be so summary about this, but requiring supervised data and kind of the tagging and all the rest of it, et cetera, led into deep learning and the opportunity to use unsupervised kind of data. We've seen it, massively with kind of generative AI over the last couple of years, and large language models and multimodal generative AI, where we can have different types of inputs on one side, different types of data creating kind of different types of outputs on the other side. But that was very brute force, wasn't it? Kind of the billions of parameters, the kind of the massive kind of chunks of the internet that were used. So it's not a surprise, is it, that kind of the next kind of breakthrough would be a less brute force, with all due respect, and very clever and all the rest of it, but kind of the idea to move to smaller models that required kind of smaller data sets and actually algorithmically were kind of super smart as well, is an evolution that not just DeepSeek, lots and lots of other companies that we're very familiar with have been working on over the last period. So I expect we'll see more of that type of evolution of AI, in particular for certain industries and in certain kind of areas and certain tasks. We'll see specialization, almost this, the same way that we saw with the transition from the expert systems, the IBM stuff with Deep Blue that beat Kasparov. Compare that to kind of what we saw with Demis Hassabis and DeepMind and Go. Okay, so I think it's a natural progression, a natural evolution that shouldn't surprise too many of us, really. But I can't really comment on the Sputnik kind of element of that. I'll hand it over to Jim if you'd like to have a shot at that one.
I think you said it best. It's all about catalysts. Sputnik was brilliant brute force engineering to launch mass to space with a signal that could be heard and have a very visceral, visible effect. And it catalyzed lots of things, industries, business, the whole so-called military-industrial complex to respond. And the response was more elegant solutions that led in the United States to things like Explorer 1, missions to the moon. And so the transition in the early frontier days of these technologies, as you said, Paul, so well, with DeepSeek versus the whole plethora of others that are out there now, is to respond to the catalyst in a targeted way to get to the next sort of quantum level of capability. So what do we need? I think AI in space needs to pick the problem space to respond to the catalyst where it can do the most good the fastest and be responsive to the problem space. Maybe it's, the AI, deep learning of living on the moon as people in an environment very different, than the TV shows with people on the moon, as we've all known and seen on various streamers, but maybe in a way that's far different than that, so that it becomes a more of a sustainable presence. Maybe that's an example. So Sputnik was great. It gave way in a very short period of time to Sputnik and those early rockets, to gigantic, massive miracles of engineering known as the Saturn V that pushed the mass to allow us to reach the moon in less than a decade, at a time when space, nothing had even been created. We went from zero, as you said at the start of these AI capabilities, Paul, went from zero to people walking on the moon in a decade, in response to Sputnik. And that is, I think, a masterpiece of engineering. The masterpiece of AI engineering, as we intersect it with space, is kind of where next? Where can we apply it with the greatest effective, I don't know, the greatest effective paradigm shift that will change how we see things. Now, I'm interested in the scientific implications. What can we discover next that will have big repercussions? But there's many other cases where it'll be more pragmatic and feedback better to business and digital economics of Earth.
I think just to add something quickly before kind of Courtney, I think we've got time for maybe one more question. What this kind of supports in my mind is kind of a focus on critical thinking within our organizations. Okay, so we know we have the capability in our workforce and our people, and we can evolve and we can develop them, et cetera, to kind of do new tasks. But what are the things, what's the direction we're going to set? What are the challenges we want to solve for? Because do you know what? They might not be the same as the types of things we could have gone after this time last year or 5 years ago or 10 years ago. So have the courage and give ourselves the space to reflect and think, hang on a second, organizationally, industrially, we, perhaps we're going to explore with doing kind of some new things. And actually now we have these capabilities, we can go after other problems that were outside of our reach before. And so I think that kind of using the technologies as a catalyst in a chemical kind of sense, to actually accelerate into those directions is going to be super valuable. Create new kind of impact, new value, new prosperity, new jobs, new etc. Courtney, do we have another question?
Yeah, we have a couple more. I'm going to actually try to answer Sandra's question. She's
good.
Curious to learn if the module will look at space data application to different industries.
Yes.
And she's talking, of course, about the business application of space program in September. Yes, Sandra, this, like Paul said, it's looking at technology as a catalyst, and you can bring your industry to the table, whether it's pharmaceutical or finance. And we encourage you to also check out the website to learn more about the details of the course. And I'm going to also try to highlight one more question if we have time. David asks, how do we engage the public in digital exploration in the same human emotional way as the public reaction to the first person to do something, land on the moon, go to Mars, even our propensity to give robots cute names? So I like this question a lot because it covers kind of how, digital exploration is perceived, whether it's for the public or for stakeholders at your company. So I thought this question was kind of interesting and just wanted to highlight it so we can rapid fire before we wrap up here today.
Yeah, how do you want to do this, Jim? Should I just give a quick 30 seconds and then pass it over to you? Is that okay? So I think what's critically important here is to think about the recalibration of kind of human and machine relationships that's at the heart of digital exploration in a complementary type of manner. Okay, not competitive, but kind of playing to each other's strengths. And so that therefore, we move past kind of the idea of automating and the fear that's sometimes associated to that around kind of our own roles and our own jobs, to getting closer to kind of the way in which these technologies and digital exploration is augmentation and assistance. And so helping us kind of improve the human condition, human prosperity, societal kind of strength, etc., means that the individual breakthroughs, those arrowheads of kind of individual kind of exploration and kind of reaching certain summits, we create a bridge that other people can pass over to have the same advantages when they get there. Okay, I think that from my perspective would be important, David. Jim?
Well, I would say, Paul, it's a beautiful question, David. The human connection to a human there is great, and that's a door opener, but that's not a sustainable one, because we don't connect with those people all the time, 24/7, because they're the courageous few, you know, who do great things, and they are. I mean, and they should be. The sustainable connection is what's important, and being a part of the exploration and the activity space. You know, wake up every day and interact with the presence on another world as we explore and do things is, you know, and I mean, I wake up every morning and there's a playback from Mars Curiosity as it's driven its, you know, 30th kilometer in the hillsides of the Gale Crater. I mean, good God. And that's a very passive interaction. Imagine that interactive being dynamic and creating, you know, the kind of things that we can imagine, you know, that link us to actually what is going on, not just by crews, but by robotics. We've talked about having robotic colonies on Mars, where the robotic systems are doing all the stuff. We're watching them from afar, engaging with them from afar. Eventually, people may be in Mars orbit doing more close by with, you know, low latency type of operations. But those are part of the equation. People really responded on a football Sunday to the return of samples from an asteroid September a year ago, as a little capsule came back with a precious cargo, because it was a human thing. We came home with something. And when we bring data home, that it connects to how we live and how we want to understand other worlds, just like robots diving on the Titanic or other great the you know history of nautical exploration have done, are really connectors. So I think it's the sustaining an interaction and connectivity that will become a growth industry as we explore new places, the moon. I mean, these cold traps, which are not a human presence kind of place, be fun, but is it necessary? And that's the kind of question I think will be engaging. It has been, as we've watched it. And so, you know, we'll have to see how to better architect that for people presence in the game, because it's their program, their money in many cases, I mean, certainly for NASA. And so we want everyone to be part of this engagement as we explore new worlds and bring it home.
May I add one final point to that? I can't remember, Jim, if it was you who shared this with me or just it was on the NASA kind of website. Listening to kind of the Mars rover kind of audio recordings of the wind, and honestly, I felt the breeze on my cheek. And of course, it's not the same as being there, but creating these augmented, extended kind of human experiences. Wow. Very valuable. So I think we've come to the end of our time. Can I personally say a big thank you to all of you for joining? Of course, it's a pleasure for Jim and I to have the opportunity to speak to you, and pass the baton back to Courtney. And we hope to see you all, okay, not all of you, of course, but as many as possible on the base program in September.
Definitely. Yeah. Paul, you've stolen my thunder. It's an amazing conversation. Thank you so much for joining. Paul, thank you for giving us your time, and Jim as well. And thank you all for checking in for an hour. There's only so much we can cover in this hour. So if you'd like to learn more from these two, please check out their new course, Business Application of Space Exploration. All sorts of applications happening on campus at MIT on September 22nd to the 26th. The link is in the comments below if you want to type it into your browser now. It's executive.mit.edu/BASE base. And we hope that we will see you there. Thanks again to everyone for joining, and have a great day.
Thank you.
Thanks so much, Courtney. Bye, Paul.
Bye.